find the derivative of y is equal to x to the x minus 2. So logarithmic differentiation can also be used to take the derivative of a function to a function, to raise to another function. Now this isn't something that you've done before. So far what you've done is, you know how to take the derivative of, say, y is equal to x squared, right? You know that the derivative of this, y prime, is 2x. So that is a power. That's when the x is in the base and the exponent is a number. You also know how to take the derivative of 2 to the x, which is when the x is in the exponent and the base is a number. So remember, the derivative of this is recopy it and multiply by the ln of the base. But you've never done it when it is, say, some f at x raised to some g at x. When you have a function raised to another function, in that case you use logarithmic differentiation, and you'll get a product rule out of this because you'll be able to use the law of powers, the logarithmic law of powers. So when we have y is equal to x to the x minus 2, what we can do is we can use logarithmic differentiation on both sides and get ln of y is equal to the ln of x to the x minus 2. By doing that, it allows us to throw the x minus 2 out front, so we get x minus 2 times the ln of x. And now on the right side, we simply have product rule. So we'll take the derivative of both sides. We get 1 over y times y prime is equal to, well, we've got quotient rule here. We've got an f of x minus 2. We've got a g of ln of x. F prime then, of course, is 1, and g prime is 1 over x. So the derivative becomes f prime g, which is ln of x, times 1, plus g prime f, 1 over x times x minus 2. So what we can do here is we can simplify a little bit more. We get the ln of x plus x minus 2 over x. We can, that's still 1 over y prime. We can get a common denominator here, and you'll get x ln x plus x minus 2 all over x. And remember that we want to get y prime alone still. So what we'll do is we'll change this 1 over y, and we'll make it y on the other side. But remember, we want to avoid an expression if we can that has x's and y's in it for the derivative. So let's get the original function in to this place. We have, remember, the original function is x to the x minus 2, right? We're pretty much done, but you can clean this up actually really nicely. You have 2 powers with the same base. You have this x to the x minus 2 and this x, which is, of course, to the exponent 1. So what you can do is you can subtract exponents on this. You can go y prime is equal to the x ln x plus x minus 2. That's still there, right? But instead of writing it x to the x minus 2 over x to the 1, so this is what I'm seeing, x to the x minus 2 over x to the 1, you can subtract the exponents to make it x to the x minus 3. Because x minus 2 minus 1 simplifies to x minus 3. And that is our derivative.